You're welcome today to my class. This is your Rose Maths welcoming you. And like we have taken our time this period to look at further mathematics questions 2024. So we have discussed question number 1, number 2, number 3, number 4. We are starting with question number 5 in section A today. So in question number 5, we have two events, M and N, such that the probability that M will occur is 1 over 2 and the probability that N will occur is 9 over 20. And the probability that M intersection N will happen is 11 over 50. Our first question is to find the probability of M intersection complement N. So here we'll start. The probability of M intersection N complement. So with that, we'll apply the formula. The formula for probability of M is equal to the probability of M intersection N plus probability of M intersection N complement. So for that, we'll substitute the given values. So we know the probability of M and that of M intersection N. Okay, we substitute, we have 1 over 2 equals 11 over 50 plus the probability we are looking for, which is M intersection N complement. Okay, we'll make this the subject and do the arithmetic. So we have 1 over 2 minus 11 over 50. Find the LCM, subtract, and the final result is 7 over 25. So all you need to know is just to remember the format. The formula for probability of M is probability of M intersection N plus probability of M intersection N complement. Okay, so this has two questions. So 5b, we are looking for probability of M complement intersection N. We'll also use the formula there, and this is the formula for it. So the probability of N happening is the probability of the intersection of M and N, and here it will be M complement intersection N. Okay, so with that done, we substitute again. The probability of N is given as 9 over 20 and that of M intersection N complement, the probability of it is 11 over 50. We substitute and we have this. Okay, so making the probability of M complement intersection N, the subject will do the arithmetic by having 9 over 20 minus 11 over 50. Find the LCM, do the subtraction, and our final result is 23 over 100. So just note the formula. If you know the formula, you can easily apply. So when you are looking for probability of N, then is equal to the intersection of M and N, and then the complement here should be on M, not N. If it is M, the complement should be on N. So note the difference. Okay, so that is it for question number 5. We'll move over to question number 6, where we have a table that shows the distribution of distance in kilometers of 60 villages from the capital, okay, from the state capital, and we're asked to draw the histogram for this distribution. I have already a video on histogram. If you have an issue with histogram after this, you can just go to that video on histogram for equal class interval and unequal class interval. So here we have distance and the number of villages. So it's a group data. Okay, the first is 0 to 19. We have 12 villages. 20 to 29. We have 7 villages. 30 to 39. We have 6 villages. 40 to 49. We have 8 villages. 50 to 69. We have 5 villages. 70 to 99. We have 9 villages. And 100 to 149. We have 10 villages. Now looking at this, I've already noticed that we are having unequal class interval. So we are going to be drawing a histogram for an unequal class interval. So here we are going to prepare the table in such a way we include the things we need. So here is a table that will help us draw the histogram. So this is what is given: the distance and the frequency representing the number of villages we have. Then the added columns here are for the class boundary. Okay, here I want to use the class boundary to work out for the distances, okay, so that the bounds would show clearly. Then we have the class size. The class size is to show the weight of the bounds, okay. And then for the unequal class boundary, you can see that we have unequal class size here. The first class is 20, the second is 10, 10, 10, 20, 30, 50. So this is actually unequal class intervals, okay. So the class sizes are not the same. And when you have such, you're going to be using the frequency density. Okay, the frequency density can be calculated by taking the ratio of frequency to the class size. Okay, the ratio of the frequency to the class size. So if you do that, you get 0.6 here, 0.7 here, 0.6 here, 0.8, 0.25, 0.3, 0.2. So having that already done, you now have your graph. Okay, so you have your graph. So in the graph, this side is for your frequency density, and here is the boundaries representing your distance. Okay, so I'll be going front to back. So for this, I will first our first distance, which is 0 to 19, has a frequency total of the boundary is from negative 0.5 to 19.5. But I'm going to ignore the negative. I'm going to start from 0 to 19.5. And my class size will be 20. And the frequency density is 0.6. So back, like I said, I'll be going forth back. So here I have, so I'll be putting the bar from 0 to 19.5, which is this. Okay, so the next one is go back again, 20 to 29. The boundary is from 19.5 to 29.5. The class size is 10, and 0.9. I think this is 0.7. So we'll go front again. So putting back what we already have. So 0.7 it is when the frequency density is 0.7, and it is from 19.5 to 29.5. So that is half of 20. That's 10. So this is 20. So the half of it is 10. So you measure it, and this is your band. So in histogram, the bars are connected. So you make sure the bars are also connected. That's why I'm using the class boundary, so that the bars will be well connected. So I won't go back again. I'll just put the other bars. You can try it out yourself later. The next bar will be from 29.5 to 39.5, and the frequency density is 0.6. You can see it's 0.6, and then the bars is from 29.5 to 39.5. You can check it out. Then the next bar, the frequency density is 0.8, and it is from 39.5 to 49.5. You can see it here. The next bar, and they are all connected. The next bar is 0.25. 0.25. Here is 0.2. Here is 0.3. So in between them is 0.25, and it ranges from 49.5 to 69.5. That is the boundary. Okay, so the next one is the frequency density is 0.3. You can see it's also connected. You just move it up, and it ranges from 69.5 to 99.5. 69.5 to 99.5. Okay, the frequency density is 0.3. The last, not the last anyway. So we have, the last, it is the last. So ranging from 99.5 to 149.5. That's the size is 50. Okay, the size is 50. That's the longest, the highest class size. So from 99.5 to 149.5, and the frequency density is 0.2. So you can see that the class sizes are not the same. This is 20, this is 10, this is 10, this is 10, this is 20, this is 20, this is 30, and here we have 50. So, but one thing is common, the bars are connected, and that shows we are having our histogram of unequal cluster interval. So try it out. If you have any question, drop it on the comment section below. Thank you so much.